Hello everyone. Welcome back to all the participants. So participants, today you'll get to see a lot more interesting things into this session because we have seen the importance of DevOps, how DevOps can make a change in the way that we develop the apps and release the apps, deploy the apps. So
Kumar, sorry for the interrupt. This is Venkatesh.
yeah, please.
This is the first class for myself. Okay. How many classes are complete in this batch as of now?
If you take into account only one session, yesterday we just started with the DevOps topic yesterday.
Okay. Okay, Kumar. You can
Well,
okay, thank you.
so participants, we were discussing about the importance of DevOps, that how DevOps can bring the way that we develop app and deploy the app. So now keeping the importance of DevOps into the picture. Now, if you have to take the role of a DevOps engineer, so what are you expected to bring as a DevOps engineer? So you're expected to bring experience in building the pipelines. What kind of a pipeline? A pipeline that might have a stage like a source where you put the code, a stage where you will do a build and test, a stage where you go ahead and do release into staging environment and then into prod environment, and then continuously bringing changes into the source code, like bringing changes into the source code, testing, building, deployment into the pipeline. So this is what is expected as part of the source code, as part of the pipeline. So companies expect that you are joining them as a DevOps engineer. So you should have knowledge about their tools that they use. Maybe they might use XYZ tools in their organization. They expect you to have the skills. So as part of the skills, they expect like we have something, a pipeline where we have source code, we have build, testing, deployment, and these are the set of tools that we use. So point is, what tools are there? What tools are making the DevOps pipeline? So participants, this is something that we will discuss in today's session much more in detail. The agenda is, we know there is DevOps. We know companies are using cloud. We know that companies are using DevOps pipeline. They have stages. They are using tools. But the question now comes here is, what tools are those? What kind of tools they use? And what is the benefit of using this tool? And I'm sure participants, most of you are aware of these tools, but it is important to learn what kind of tools that we would be using much more in detail, because this is how pipelines are built. So participants, can you tell me what is the best way to start? Participants, what is the best way to start a pipeline? What do you think? Where should we start a pipeline? Anyone, any guess?
Plan.
Very good. We can start planning. So planning is basically done in terms of business teams. Business teams will plan, but we are technical consultants. So we are on the implementation side. So participants, what do you guess? What should be the best way to start if you are technical consultants? Source code. Because you will work with the developers. The developers are expected to write the code, and you as a DevOps engineer will do the complete administration on a source code management. Clear, everyone? See, what you said is absolutely right. Planning is the place where the entire pipeline will start. But planning is majorly by your managers. Managers will plan, right? Saying that this is the kind of plan that we have for our DevOps release. This is our, you know, future release. This is our release. On this date, we will release. This is the task for you. This is the task for me. These are the tasks that we have allocated for the developers. So that is purely about project management planning. Now, we will do that, but that is not the technical aspect of a DevOps engineer. So I did consider source code management, where we go ahead and create a source code management tool, or we will use source code management tool so that developers can start writing the source code. Participants, can you give me some examples that you are working as part of the source code management tool? What are the tools that you have worked at? Participants, what are the tools that you have worked?
YAML.
Pardon?
YAML.
YAML. Apologize, I didn't get that. Can you spell it out? I'll write it for you.
YAML. YAML.
YAML.
Yeah.
YAML is a programming language, if I'm not.
We use the GitLab.
GitLab, correct.
Bash.
Type in source code management tools. You'll get plenty of tools listed. So, question is, when there are tools, what is the purpose of these tools? So, GitHub is the world's populous tool. When you go and ask, if you ask by default, a lot of companies have their base with regards to GitHub, because GitHub is now part of Microsoft.
Oh. Huh?
Participants, a kind and a genuine request to every participant joining in the session. Please do check your audios, whether you are on mute, whether you are on whether you are unmuted. Please do check it out. Have a gesture, a good gesture for other participants as well. Maintain the cleanliness of the session and don't overuse the privileges that are given to you. Please, genuine request. Yesterday also I've requested the same before starting the session, that please make yourself muted. If you are on, if you are unmuted, please check your. The session is getting recorded, participants. This will be used by you people. So unnecessary creating confusion and noises will really impact. I apologize on behalf of the participants who are creating noises. I would request once again to other participants, please check your audio. If you have a question, please feel free to ask me. Okay. Now, let's come back to the discussion, participants. So we were discussing about GitHub. GitHub is the world's preferred version control, where organizations prefer to go ahead and put their code. Now, what happened, people? Even companies like the cloud companies have started to offer their own version control tools. Like just an example, if you go ahead and hit AWS, in AWS, there is a service called code commit. That is the version control. I don't know how many companies use it, but do companies use it? A lot of companies use it. In Azure, we have something called Azure repos. AZ repos. This is where you will put your source code. The advantage of using AWS and Azure is they are backed up by huge cloud base. So you can get unlimited amount of storage from both of them. Apart from that, these services are readily integratable with other services in the respective clouds in AWS and Azure. And both of them are private hosting services. Private in the sense, the code that you place is not going to be publicly visible. It's going to be private. But whereas other tools, most of the tools prefer providing support for private as well as public, like the source code management tool, which is GitHub, as an example, do provide public repositories and private repositories. Let me just show you a glance of my source code. Participants, this is my source code, which is GitHub. You guys can see there are repositories. There are certain public repositories I host, certain private repositories I host. Okay, are we good, participants? Can we move on further? So your code is placed into the source code. Now the next step is to start building that code. We need to start building that code. So participants, build is part of the pipeline. The next stage in the pipeline is to start building. So it depends on what kind of programming are you involving while writing your source code. The build will come in. So participants, if you go ahead and look for the build tools, let's go ahead and look for build tools, build management tools. There are plenty of build management tools that are available. Like Apache Maven, Maven. Gradle is another popular tool under the build management. So participants will try to remain as much as possible. Like while we program involving source code for an application, if I want to write an application, I prefer to use options like I want to use an application development written in Java as much as possible. If required, I might use .NET also for the purpose of making you understand. And I would like to not to go ahead and write a complex code, participants, because that is not the role of you writing a Java code, because we are not developers. We are not developers to write a Java code. We are focusing on how to use a source code written in Java into our pipeline. That is our plan. How to consider a code that is written in .NET and deploy this code. Because we are not developers. We are helping developers. Developer in this pipeline is only one role. Write the code. That's all. It has nothing to do. From there, everything is something that I will do. That is the DevOps engineer will do. So for that, I have given the role for the source code developer, the developer to write his code into source code. That's it. Next, I will go ahead and handle the source code given from the developer with regards to build. I build my code using tools like Maven, Apache Maven. Maven is going to support your Java code. MS Build is the build tool. If I'm using .NET code, I will use MS Build, which is my build tool. Am I clear to all of you participants? Hello, participants, am I clear?
Hi Kumar, can you repeat this again?
No problem.
Thank you.
Assuming that participants, I'm going to be using a source code because I need to use a source code. Assume that I go ahead and write the source code in Java, just a Java code. If you want, we can use a simple hello world code. And I would like to go ahead and deploy this hello world code into cloud. So the code is written in Java. I need to build it. So what is a supported tool? I'm going to be preferring to use Maven. You can change Maven with any other tool. When it comes to .NET related code, we will use .NET code. For that, we cannot use Maven for that. Maybe you can use it, but that becomes very complex for you to handle at this moment. So .NET projects are heavily built on MS Build given by Microsoft. So we can integrate with MS Build to build our project. So the tools that will come across are like Maven or MS Build as part of your build tool. Are we good, everyone? Participants, are we good?
Yes.
Now,
If you are writing the code in the JavaScript, what is the build tool we can use?
JavaScript.
Yeah, if it is Java, we use Maven, and if it is .NET, we use MS Build. You said, right? So if
Right.
it is like other language kind JavaScript or Salesforce code,
Right.
anything.
Very good. So keeping this as a benchmark, like Maven with regards to Java, .NET with regards to MS Build, assume that there is another programming language. So most of the time, your company or organization will tell that we are using currently some X compiler or X build tool to build the project. So if you have experience with Maven, we would request you to go ahead and build your skill set on that X tool. That's how organizations allow you to do so. Give you time to go ahead and integrate based upon the experience you have with regards to build tools like Maven, Gradle, MS Build to next tool. That is, if it is front end involving a code like Angular, Yarn is used. So they'll allow you to build that skill. That's how the community, that's how expertise are built. Clear?
Okay. Yeah. Okay, got it.
Now, participants, there are two set of categories that we are discussing here. One is integration, imaging, and provisioning. Okay, let me do one thing. Let me just remain at this moment in CI tools, continuous integration. Now, this segment is the powerful segment in DevOps engineering. Very, very simple. Continuous integration means this tool has capability to integrate every other tool into the pipeline. It can integrate, and the world's preferred tool under the continuous integration is Mr. Jenkins. Jenkins is 90% of the usage, which is continuous integration. 90% is with Jenkins. The share of the continuous integration is up to 90% when it comes to Jenkins. And so preferred tool, whether it is a billion-dollar company, whether it is a startup, I've seen Jenkins as a preferred tool. I don't know how about other companies. I don't want to comment, but even if you work for top clients, they would be greatly interested towards Jenkins. Nowadays, when it comes to cloud, we have alternatives to Jenkins. Cloud providers have alternative to Jenkins, but the way Jenkins is very different. You get to see when you come to cloud, you have similar tools, continuous integration tools like pipelines. In AWS, we have pipelines in Azure that actually replicate the idea of Jenkins, what Jenkins do, but not to extend what Jenkins does. So let's keep ourselves focused in the continuous integration segment with regards to Jenkins. There are tools similar to Jenkins like Travis, CodeShip, CI Circle, but I don't think so. Especially when it comes to continuous integration, no one can beat Jenkins. From there, once the integration is done, participants, now we have to start deploying things, keeping in mind that we will start moving into cloud. Tools that come into picture for provisioning. Now there are provisioning and that too, two things. Provisioning and imaging. These are two things that I would feel people, let's keep these things a little aside for some time because this is purely targeted towards cloud. So I'll come to this option discussion a little later, but let's keep them in the ball game. Let's keep them because they are the game changers when it comes to cloud. So what I will do, instead of focusing them at this moment, I'll just mention that there are two segments that we will majorly focus for the cloud part involving imaging and provisioning. We'll come to that later. Next, configuration management tools. Participants, have you come across any time configuration management tools? Now, this is the highest level of engineering that I've seen. Configuration in the sense, when you start handling a single server, you can handle it. But when you scale these servers from 1 to count of 100, it becomes challenging for you to go ahead and handle your resources. Example I've given is server S1. Now it has up to 100 servers. I'm giving you a task. The task is to go ahead and deploy a package. I would ask you to go ahead and deploy a package. That package needs to be deployed across all these 100 servers. Manually, it's really impossible. It becomes nearly impossible for you to do that in a given time. So as a DevOps engineer, if you are given this task to deploy a package, it's going to be really challenging for you. Because in DevOps engineering scenarios, you will see scaling of those machines, auto scaling of those machines taking place. So when auto scaling takes place, you don't know what is the end count. Maybe 100, 200, I don't know. The number keeps on growing, servers keeps on growing. And deployment is going to be a challenging job for you. And that is where configuration management tools come into picture. An example for this is Ansible. Ansible is world's preferred tool when it comes to configuration management. It doesn't mean that that is the only tool. There are other tools, configuration management tools like Salt Stack. Participants, are you with me, everyone? So just keep these two tools a little aside for some time. And I hope you got a clear picture with regards to source, build, continuous integration, configuration management. Can I proceed a little further, people? Hello?
Yes, Kumar.
Yes.
Okay. Now, you have built your code, taken from the source code, you are integrating it, and now you are trying to go ahead and, I'll not say enter into cloud, but let's say you want to go ahead and deploy somewhere. You want to deploy in your local machine, you want to deploy in your cloud server, you want to deploy somewhere, you want to deploy. Deployment tools will come in. What comes now is continuously I want to do a deploy. So participants, continuous deployments are kept in mind. Once again, cloud, because in local machine, what is there for you to deploy? Okay. But let's say you have a cloud machine. How do you deploy? So here we would be using cloud services as much as possible for our continuous deployment. I would say, if you ask me, what is the kind of CD deployment that you're preferring? I prefer Jenkins to do the job of deployment also. I can categorize Jenkins into CI and CD, which is going to be continuous deployment and continuous integration service, which will do deployment. But when it comes to cloud, I have to use cloud services. In AWS cloud, we have, in Azure cloud, we have, in GCP, we have code deploy AWS service. Code, cloud deploy, code deploy, cloud deploy, different names they'll give in cloud. Now, with this, I can say participants, I can happily build a pipeline and deploy it. So before that, before going to the next segment, I have a question. How many of you heard a word called Docker? How many of you heard a word called Docker? How many of you heard a word called Kubernetes? How many of you heard a word called Docker or Kubernetes?
Storage.
Docker is for container.
Very good. Both Docker
Kubernetes.
and Kubernetes,
Container. Both.
they are container technologies. What is a container? Anything that contains something is a container. Anything that contains something is a container for me. A box where you put your items is a container. Are you with me, people? Hello? Put something,
Yes.
close it. That's a container. Same way, container concept is available in application development. In application development means developers have adapted to container technology. That technology was brought to us by a company called Docker. The name of the company is Docker. They have introduced a technology called container technology. So what they have done, people, is they have taken the project source code, or they had some source code. What they have bundled it with all the insights with regards to working of this code. In order to make this code work, they take all they need, they make it as part of one box container, they contain it, they containerize it. Now, this container concept has really changed the way development has started to take place. A lot of companies said, why are we spending time this much when this kind of technology is readily available? They have adapted to container. Developers have adapted to container technology. So what they do, they go ahead and give you the source code. Now you are a DevOps engineer. They'll ask you to create containers. So participants, the way adaptation to Docker has changed, you will also have to go ahead and adapt to containerization. See, in last few years, if you see the adoption of containers, they are very, very heavy. A lot of companies have adapted to containerization. Kubernetes they have adapted to. So the idea is for a containerization that there will be a source code where the code will be taken, it will undergo build. Instead of just building, you will build here containers. You will build container images, we call it as. Everything will remain the same part. There's nothing going to change. Instead of you building the source code, you start building container images as a DevOps engineer. Everyone, are you with me? Hello? Everyone, are you with me? Hello?
Yes, sir.
Yes.
Yes.
What is container? Yeah, please continue. There was someone trying to ask me a question. Okay. So what is this container going to do? So this container is something gonna come with all that you need. So developer will write the code. That means we need to bundle the source code. In order to build the source code, we were using build tools. So we will bundle the build tools. For example, Maven. After the build tools is done, we will go ahead and integrate with all the packages that we need to run packages. And that's it, participants. It's a ready-made solution for you. It's a container. So use this container and deploy this container. That's it. That is where Docker comes in. And if you target at a high production grade cluster management where thousands of containers do run, which cannot be handled manually, then we have to adapt to something called container orchestration. And that container orchestration is Kubernetes. Everyone, did you understand the power of now Kubernetes? Kubernetes is so powerful that when you go ahead and build a simple image, even a hello world image, if you build and ask, go ahead and spread in 100 to thousands of containers that are running across, you have to go ahead and adapt to such a technology which can handle these number of containers, hundreds to thousands of containers, scaling them, production grade deployments you have to handle. So this cannot be done manually, and that's where the breather comes when you adapt to Kubernetes. Kubernetes is available in many things. In AWS Cloud, we have under the name of EKS, Elastic Kubernetes Service. In Azure, we have AKS, Azure Kubernetes Service. EKS, Elastic Kubernetes Service. Azure Kubernetes Service. Everyone, are you with me, people? Hello? Participants, everyone, are you with me?
Yes.
So now we have seen a source code playing a vital role where we put our code. We go ahead and build our code. A source code may be written by a developer, maybe using a language like Java or .NET or any other language. Build tool where we go ahead and build the artifact. If we adapt to containers, we use build tool as Docker to build Docker images. When multiple tools come into picture, we need to do a continuous integration, integrate one tool with regards to another tool, like Jenkins will come into picture. When we move to cloud native integration tools are available into the respective clouds, AWS and Azure. So keeping this discussion a little aside, there will be scenarios where you need to handle hyperscale environments that involves multiple resources, especially the machines like cloud machines or virtual machines. In order to handle configuration management, so we need configuration management tools. In order to deploy the code into those machines, maybe cloud machines, maybe cloud instances, maybe virtual machines on-prem, deployment tools is required. And when we adapt to containers, we are focusing on building images, which are container images backed up by technology like Docker. And when you target a hyperscale deployments involving thousands of containers running, thousands of container images that are running, we need to adapt to container orchestration. And that is where Dockers and Kubernetes have a very vital role to play. Are we good, everyone? Hello, participants, are we good? Are we good?
Yes, Kumar.
Yes, Kumar.
Now, from there, every project will have a need where administration, management will come in, monitoring will come in. Because if it is one machine, it's okay. We can go ahead and monitor that machine. But when it comes to thousands of machines that are running inside your project, monitoring them, logging them, managing them becomes a very challenging job. That's a very challenging job. So we need those machines, or we need those kind of tools where we can track their continuous monitoring. So here also we will be very specifically using cloud services when it comes to monitoring and logging. Because see, if it is one service, participants, if it is your local machine, your instance, your local machine, what you will do with your local machine? What you will do with that monitoring? Nothing. You cannot go and even do nothing with that monitoring. But when it comes to cloud, yes, it is a scaling that will take place. So we need monitoring tools. So cloud monitoring tools are going to be our tools. And this is the latest buzz that is happening with regards to inspection. The name itself is telling you, hey, we are inspecting something. What is that you're inspecting something? The inspection says a developer might be writing an awesome code for us, which might be well versed to do the action. It might do what you want. But is he following a standard to do that? Is he following the way it is required? Let's say I'll ask my developers, hey developers, when you're writing, make sure that you go and put some standards by making sure at regular places, put some comments wherever you're writing, put some comments. Instead of using for loops, try to use series. Don't go ahead and, put unnecessary loops, which are open loops, and don't keep variables that are not being used. So I put my standards. I say that don't use variables as much as when you're not using those variables, remove those variables. So if I go ahead and put all this into a tool, that tool will do the inspection on behalf of me and tell, hey, your code is not following the standards that were set by Mr. Kumar. Are you sure? And it will give a score for him. Hey, your score is only 50%. My standard is 80%. 80% the code has to get inspect. 80% of the code is something my score, then only he will pass. Otherwise, I'm going to make him fail. I'll make him fail. The moment he'll fail, the code will not get approved. The code will not get released. Code inspection tool. Anyone who's aware of any kind of code inspection tool in your current job you're using? Lint, Sonar Cube. These are the tools that are designed to do the job. Code analysis, they will do analysis on your code. So these are some extra tools that are on top of, I would say, on top of our tools that are really required. Some add-ons. Inspection is an add-on, monitoring is an add-on, logging is an add-on, administration for all add-ons. Add-ons in the sense, without them, you can build a pipeline, but it is good to have them into the pipeline because they'll help you to monitor your resources. They'll help you to inspect your resources. Everyone, are you with me, people? Hello? Participants, everyone, are you with me?
Yes, Kumar.
Yes, Kumar.
Yes.
Okay. Now, it's just an example I wanted to show you. An example. Let me just pull them. I'm trying to drop them here. All those tools that I just started to discuss, like I highlighted about GitHub. There's a similar tool like Bitbucket, Maven, Jenkins, Packer, and Terraform. Participants, just keep these two tools. They're very interesting tools, but if I go and talk with regards to these tools, they will be very confusing because you will not understand what is an image and what is provisioning. Just keep these tools a little aside. Chef and Ansible to come into configuration management tools. Jenkins is a deployment tool, monitoring tool, Sonar Cube, examples, Docker, Kubernetes, orchestration, In your local machines, you can create machines. In your local system, you can create virtual machines involving virtualization technology by adapting to VirtualBox, and infrastructure as code as writing the code in Vagrant, cloud like AWS and Azure. Are we clear, everyone? Hello, participants, are we clear?
Yes.
Yes.
Kumar.
Yes.
Just an example architecture. To bring an example architecture for you. So it is a source, build, test, deploy, provision. This is a pipeline that I want you to memorize. Participants, this is something that I want you to memorize. This is a kind of a pipeline that you should go ahead and expect. Source code. Participants, tell me, what is the source code that you are now aware of? What are the source codes that you are aware of? What are the source code, participants?
Git.
GitHub or Java, like yeah, GitHub.
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 There are plenty. Just I'm trying to buy.
GitLab.
GitLab.
AWS commit.
AWS code commit. Very good. Azure repos.
Azure. Bitbucket also.
Bitbucket. Yep. Build tools that you feel that can fit this build pipeline.
Maven.
So if it's Java, Maven.
Let's build. Yep. Docker, Gradle. Lot of tools. You can use build and testing together at this moment. Participants, deployment tools. Jenkins. Provisioning. At this moment, let's keep the idea of provisioning more towards cloud. If you ask me provisioning tools in cloud, provisioning for image, I will use Packer, Terraform in AWS, Azure, any cloud it will work. Packer and Terraform. And CloudFormation, ARM templates. CloudFormation is from AWS, ARM templates from Azure. Monitoring.
CloudWatch.
Okay. Participants, now what I would like to do is I would like to take your questions. Do you have any questions from your side, participants? Participants, do you have any questions?
Hey Kumar, would we be getting access to any training material like the PPT that you're showing or anything other than that? Like,
I'll park your question for some time. I'll definitely answer that. Any question on the content, participants? Content, like, you have, what did you have any questions related to the technical aspect of what we have discussed now? Is like, if you did not understand anything with regards to the slide, do let me know. Specifically on this part.
Kalyan, sorry, Kumar, I'm sorry. Can I speak?
Yeah, please.
Actually, today is my first day. Whatever you thought today is good. Like I understood, but actually, is this the continuation of last class? Like, could you, if you don't mind, can you give a recap of last class?
Awesome. So participants, the recap of the last session was purely about this one. So we did start yesterday. Today we have started from here. Yesterday I did spend some time on discussing about introduction to DevOps. Introduction to DevOps, we spent time in understanding the situations, how life was before DevOps. We try to understand the challenges, day-to-day challenges, because the DevOps is all about involving two set of people like dev team and ops team. So we did try to understand what a developer would do on a day-to-day basis. what are his job roles, what he will do as part of it. And then we have understood what is the role of an ops team, what they do. And then we have looked for an alternative, or we have looked for a solution that can help teams to work together. And that's where we found DevOps can become a better solution. And as part of the DevOps, I tried to go ahead and introduce the concepts of DevOps, involving how a solution. So Sharon, could you please check your audio? Right. So participants, then we found DevOps is the best solution to handle this kind of requirement when two different stakeholders and two different teams are involved, where they can be built together by the idea of pipeline, a pipeline that connects multiple environments. I will go ahead and prefer to use pipelines to connect these environments. So one environment, what happening is going to give you visibility to another environment. So the pipeline concept did come in. So I've introduced what is pipeline. I talk more about pipeline. From there, what I have spent time is the official definition for a DevOps. I gave them how companies would go ahead and do DevOps and why it is required for them. What is the benefit? Because the target is whatever they do, they're doing it right, but they wanted to make it fast. They want to fail fast. Participants, today's world is doing this logic. They will fail at every point, but they will recover at fast pace. If you don't follow this approach, participants, you will only be failing, but you will not do that. So participants, what you also have to do as a DevOps engineer, you have to fail, but you have to fail fast and move on. This was said by my project manager that when it comes to DevOps, Kumar, you have to adapt to fail fast. Participants, this has really changed the way I have handled my DevOps engineering. Even it is applicable for you. When you come into DevOps, you'll keep on failing. But it's not that failing will have to stop you. You have to fail fast and you have to keep moving on. Remember this word, fail fast. Because the faster you fail, the faster you will find a solution to release. Okay. And then participants, we did come into the discussion involving what is the backbone for your DevOps engineering, CI/CD modeling, continuous integration and continuous deployment. What are the different stages in continuous integration? What base stages that you will get to see in continuous deployment, and how these two services are related, or how these two services are going to be backbone for your pipeline. That's how I introduced the pipeline. A little discussion we have spent on this benefits. I don't want to go into the benefits because this is purely not to us, it is purely to the company business. From there, I introduced the concept of pipeline. So today, the next part of the pipeline was purely about how stages, what kind of stages we have. And if those are the stages, how you go and build a pipeline, and what is that going to make a pipeline? How is that pipeline will be built? So for that, categorization of tools was required for me to spend time giving you each individual category, importance of it, examples, and the list of tools that we can get to see under each category and how do we use it. And now participants, once you get to see this, now we have to take considering a build pipeline. Now we have to start building a pipeline. For that, we need every tool that is possible. The next steps would be getting each category of getting a tool from each category, installing on your machine and doing the build pipelines. That is the next target. Clear everyone? Are we good, participants?